Hello, welcome to Chapter 8, Section 4, factoring ax squared plus bx plus c. We're working problems 7 through 12, the guided practice problems on page 552. So for all these problems, the last parameter, the last coefficient, constant, is going to be positive. And of course, because of the diamond method we're going to be using, that's really not going to matter. So you're just going to see me do 6 problems in this video and 6 problems in the next video of just practicing the skill. As always, when I record these, I'm kind of going at my own pace. I'm also being mindful of the fact that I don't want to make the video longer than it needs to be. So if you're in a situation where it's like, whoa, that didn't make sense, just pause it, rewind it a little bit, and go back to where it was. Okay, watch it again, or just hit that pause button every now and then. What you can do, and I've said this before, what you can do is you see the problems I'm already working right there. Problem 7 and 8 are right there, and here's the rest of them. You can even pause right now, do number 7 on your own paper, and then watch me do it and see if I got what you got. And that's how we would actually do it if we were doing it in class. I'd put these problems up on the board and I'd say get started with your partner, and then I'd show you what it is. But the video is basically just me all by myself doing it. So let's get started. So the A is 5, the B is 11, and the C is 2 for my so-called diamond. And I know they draw the diamond around it, but I usually don't do that. I take the A times the C, 5 times 2, and put 10 here. And I put the B down here. Then I ask, I want 2 numbers that multiply to give 10, but add to give 11. Well, that's easy. That's going to be 10 times 1 equals 10, and 10 plus 1 equals 11. So in my multiplication chart, and I'm going to make it a little bit bigger, in my multiplication chart, I take the 5x squared and put it in this corner. I take the 2 and put it down in the other corner, opposite corner, upper left, lower right. What goes here and here come from these numbers that I just found. So I write 10x and 1x. And again, you can just write x, but remember there's a 1 there. So all of this together gives me this, 5x squared plus 10x plus 1x, which is 11x, plus 2. So basically, the whole point of this is to take this polynomial, this quadratic polynomial, and separate it so that I can figure out what I got here. What did I add together to get here? I'm just working backwards. You remember that all the stuff we did in chapter 7. All right, so now I'm going to factor it like we've done before. Factoring across the top row. This is 5 times x times x. This is 1 times x. What do they have in common? Only the x. What got left behind here? The 5 and the other x. What got left behind here? The 1. X times 5x equals 5x squared. X times 1 equals 1x. What do these two have in common? This is 2 times 5 times x, and this is 2 times 1. So it has a common 2. Let's check. 2 times 5x is 10x, and 2 times 1 equals 2. Where it says check your answer, that's embedded inside this, because after I factor it, I remultiply to see if I got it right. So my factored form is going to be x plus 2, that's this part, multiplied by 5x plus 1. That's the part that goes across the top. So you remember when we did this in chapter 7 and we multiplied? We're just doing that same skill backwards. That's all that it is. Number 8. 2 times 5 is 10. And my 11's here. That's really weird. That's like the same as this one. Huh. So again, this is going to be 10 and 1. I have 2x squared here. I put my 5 in the other corner, and then these two corners are going to be my 10x and my 1x. So what's my common factor between 2x squared and 1x? Just x. That leaves 2x and 1. And what's my common factor between these two? The 5. 5 times 2x is 10x, and 5 times 1 equals 5. So factored form, I get x plus 5 times 2x plus 1. Every time I do these problems in class, I always wonder why Dr. Berger wrote two very similar factoring problems side by side, problem 7 and 8. Because this one's 5x squared plus 11x plus 2, this one's 2x squared plus 11x plus 5. I don't really know, okay, unless the authors are just trying to say, hey, if these two things switch, you're going to get different factors. But of course, to me, I would think that that would be kind of obvious, but who knows? All right, let's plug through with the rest of them. 4 times 5, the A times the C, the first times the last. 4 times 5 is 20. The negative 9, the B, goes down here. Now, these two numbers multiply, and the answer is 20, but when I add them, the answer is negative 9. The product is 20, the sum is negative 9. The only way for that to happen is if both of them are negative. So then I start thinking about negative 20. So that could be negative 1 times negative 20. That sum is negative 21. That doesn't work. Negative 2 times negative 10. That would give me negative 12. That doesn't work. Negative 3 doesn't work. Negative 4 times negative 5. There you go. There's my winner. Negative 4 times negative 5 equals positive 20. Negative 4 plus negative 5 equals negative 9. 4x squared goes in this corner. 5 goes in this corner. Sorry, I got the hiccups. Negative 4x plus negative 5x equals negative 9x. So here's my negative 4x and negative 5x. And like I said in the instruction videos, these two can switch places. Everything else has to go where they're supposed to go, but these two can switch places. What do these two have in common? Just the x. That left 4x minus 5. What do these two have in common? The number 1. The greatest common factor is just 1. But 1 times 4x does not equal negative 4x. But it does if I change it to negative. Negative 1 times negative 5 does equal positive 5. So like you saw in the previous videos where we factor by grouping, if I have positive, negative, positive, that means I have x subtract something and x subtract something else. So I get x subtract 1 times 4x subtract 5. Two times 14 is 28. Negative 11 goes here. What multiplies to give positive 28 but adds to give negative 11? Again, both of them have to be negative. So negative 1 and negative 28, that doesn't work. Negative 2 and negative 14, no, that adds up to negative 16, that doesn't work. Negative 3 is not a factor. Negative 4 and negative 7, that works. So negative 4 and negative 7. 2y squared, and they switched it to y, so I have to make sure I say y. 2y to the second power goes in this corner, 14 goes in this corner. The negative 4y and the negative 7y go in these corners. And again, it didn't matter which one I put here, it doesn't matter which one I put here. What do these two have in common? In the first row, they both have a 2y. That leaves y, subtract 2. What do these two have in common? They both have a 7, but when I check 7 times y and 7 times negative 2, the signs have to switch. So I'm going to put negative 7. Now everything is going to match up. And I get 2y subtract 7 times y subtract 2. And I'm glad that I didn't accidentally write x. Number 11. 5 times 4 is 20. 9 goes right here. I need two numbers that multiply to give 20 and add to give 9. Everything's positive, so everything's going to be these are positive, so everything's going to be positive. I can go through my list. I can do 1 times 20, 2 times 10, and I get to 5 and 4. 5 times 4 equals 20, and 5 plus 4 equals 9. So 5x squared, 5x, 4x, and 4. The 5x squared and that 4 come from here and here, and the 4x and 5x come from here and here. What do these two have in common? They both have a 5 and an x. That leaves the other x and 1. What do these two have in common? They both have a 4. 4 times x is 4x, and 4 times 1 equals 4. So in factored form, I get 5x plus 4 times x plus 1. And problem number 12 for this video, the last one for this video I should say, 3 times 2 equals 6. The 7 goes here. What two numbers multiply to give 6 but add to give 7? That's going to be 1 times 6 equals 6, and 1 plus 6 equals 7. So I start to fill this in. 3x squared, 1x, 6x, and 2. The 3x squared came from here. The 2 came from here. The 7x gets split into 6x and 1x. What do these two have in common? Only the x. That leaves 3 in the other x and 1. What do these two have in common? This is 2 times 3, this is 2 times 1, so they have a common factor of 2. Let's check. 2 times 3x is 6x, and 2 times 1 equals 2. So my factored form is x plus 2 times 3x plus 1. We'll see you in the next video.